Okay, composition of functions. Let's first back up and just think about functions. F of x is 2x minus 3. G of x is negative x squared plus 7. And in fact, let's just call these warm-ups. Let's find f of 3. Let's find g of negative 3. G of 2x, and f of a minus 1. All of that should be review stuff, right? F of 3 means look at the f function, plug in 3. Look at the g function, plug in negative 3. Plug in 2x, plug in a minus 1. So take a couple minutes and make sure you're okay with those. I hope that's true for most of you. But let's see, f of 3, so I grab the f function, plug in 3, 6 minus 3 is 3. That was the easiest of the bunch. G of negative 3, that's where we start losing people, because people don't know how to handle their negative numbers. What happens when we square negative 3? Positive 9. And then I put the negative on, and so now it's, we've got a few people fixing things. Negative 9 plus 7. Negative 2. Can I help you?
In your calculus classes with seniors in it,
yes.
Would you mind asking if they took AP Chemistry and just passing these out?
Certainly.
So that they get their core?
Sure.
Thank you so much. I know it might not be as many kids in this class, but
yeah,
this is the only way to get it through their math teachers.
No, that's fine.
I'm going to keep these, and then to just fill this form out and bring it to Miss Walsh. They probably already know.
Okay.
It's in Miss Walsh's room. Thank you so much. I appreciate it.
Thanks. Okay, g of 2x. So we'll grab the g function, and instead of x, we'll replace x with 2x. Right, whatever's in parentheses is the input to the other side. So negative square of 2x plus 7. So if I square 2x, then you said it, 4x, what?
4x to the power of 3.
If I square an x, I just get x squared. So negative 4x squared plus 7.
How is that the case?
Because I'm going to take whatever's in here, goes in on the other side.
But like, you get 2x, then the nerve ends is equal to 2x, and then you multiply it. So you try to win that.
2x times 2x?
Oh wait, I'm stupid. Alright, never mind.
There you go. F of a minus 1, so I'll plug in a minus 1, right? Whatever's in parentheses goes in on the other side. So that would be 2a minus 2 minus 3, 2a minus 5. I hope you got all those right, because you need to be able to do that for what we're going to do today. And what we're going to do today is maybe a new symbol for you. F, a little open circle, and then G. Have you seen that before?
My friend showed me that because he was in calculus, and he showed me that open circle. It was like, what the heck is that open circle?
Well, that's what we're going to talk about today. What the heck is the open circle? Because that is a little bit weird looking, maybe, if you have, especially haven't seen it before. How we say it is f of g of x. It's not an official term, but some people, kind of a slang, will just say fog, because that's kind of what it looks like with the open circle there. It's not an O, it's not really fog, but it kind of looks like it, so people looking to abbreviate.
Anything on multiplication?
It does not have to do with multiplication. That's a great question, because f dot g would be f times g. That'd be multiplication. F of g, here's a better way to write it that makes it easier to see what's going on. F of g of x. F of g of x. I don't like it when it's written as the fog way. I will almost always change it to f of g of x, because that makes it easier for me to work with. Okay, well, remember, whatever's in parentheses for f, we plug in on the other side, right? F of 3 meant plug in 3. F of a minus 1 means plug in a minus 1. F of g minus x means we'll plug in g minus x. So g minus x is negative x squared plus 7. Right, that's what g of x is. And now that becomes, that whole statement, that whole piece of stuff, becomes the input to the f function. So now I'm looking at the f function. Instead of plugging in x, instead of plugging in 3, instead of plugging in a minus 1, I'm going to plug in negative x squared plus 7. So the f function is 2 times the input minus 3. That's what the f function is. And again, the first thing we did was plug in 3. Later we plugged in a minus 1. But right now we're going to plug in negative x squared plus 7. And then distribute and clean up a little bit. Negative 2x squared plus 14 minus 3 is negative 2x squared plus 11. So my best suggestion is when you see fog, rewrite it as f of g of x, and then all you're doing is following directions. You're plugging in g into f. Anybody want to guess what the next example is going to be? This one was f of g of x. Let's switch the order and let's do g of f of x. G of f of x. Again, I don't like the Goff presentation of that. I would rather write it as g of f of x. Like that. Because if you write it like that, that's telling you what to do. It's telling you to use f as the input to g. So I think what I would first do is plug in what f is. That's 2x minus 3, because that's f of x. And then now I'll go grab the g function, which is negative input squared plus 7. That's what the g function is. Negative input squared plus 7. And my input this time is 2x minus 3. So I got a little work to do. I need to square 2x minus 3 and then put the negative on. But close. Let's see. 2x minus 3 times 2x minus 3. I'm going to be careful. I'm going to make sure I FOIL first and then put the negative sign on there. I think if I try to do too much at once, I'm probably going to mess something up. So 2x times 2x. 4x squared. We FOILed enough now that I'm going to combine a step here. The O and the I terms, they're both negative 6x. So save me a step. What happens when I combine them? Negative 12x. And then plus 9. If you need to show more steps, then by all means show more steps. We still have the negative out front, so let's distribute that to everybody. And then we'll collect like terms. The only thing we've got is the constants at the end there. Negative 4x squared plus 12x minus 2. So feels like there's sort of two parts to this problem. There's the new concept part of recognizing that g of f of x means use f as the input to g. And then there's the calculation part, which in theory we already know how to do, but there's lots of mistakes to be made in there. So you've got to get the concept right, and then you've got to get the computation right. let's try f of g of -1. Okay, this one's, I guess, a little different because there's a number in there, but it's the same process. First thing I'm going to do is rewrite that as f of g of -1, because I think that's easier to deal with. So what should I do first? What should I plug in to where?
Plug in F.
Start from the inside, right? When you have parentheses in math, you start on the inside. So what should I plug in where? What should I plug into G?
Negative.
Yeah, so I need to first find
-1 squared.
I need to first find G of -1. Yep, -1 squared plus 7. So can you do all that in your head without messing up the minus signs? What's negative square of -1 plus 7?
Yeah, but the answer is 6.
Answer 6, right? This becomes -1 plus 7 is 6. So G of -1 is 6. And now I'll find f of 6. So now I'm going to go grab the f function and plug 6 in. 2 times 6 minus 3. 12 minus 3 is 9. So my answer is 9. It's like a nested function thing. But you do like you always do in math. Start on the inside and work your way out. You know how to find G of -1, so find that, and then that becomes the input to the next function out.
Because your calculus is this.
Yes, and what we just took a test on was finding derivatives of these nested types of functions. It's called the chain rule, and it's related to eating flow pops. But I'll tell you more about that in 2 years. How about G of 0? Why don't you try this one on your own? I'm going to rewrite it because I think it just looks better and easier if I write it as G of 0. So, and then we'll see if your answer is correct. So, what am I finding first? What am I plugging in to what function? 0 into G. So job 1 is G of 0. So I look all the way back up at the G function and see that whatever the input is goes right there. Well, that one's not hard. I square 0 and make it negative and add 7 and I get 7. So G of 0 is 7. That means that 7 is now the input to the next function out, which just happens to be G again. So I'm still using G, but now I'm going to plug in 7. So yes, 7 times 7 is 49. And negative 49 plus 7, oh good, I heard this answer from somebody, negative 42. Did you get it, Ben?
Yeah.
You were the first one to get it. That's a bold claim. So if you understand how function notation works, this really isn't that bad. Just work from the inside out. Do what we've always been doing. Find G of 0. But now there's an extra layer to take that answer and plug it into whatever the next one out is. 2 more examples. I turned the page, so I'm just going to rewrite what f is up at the top, just so it hasn't changed. So if you're still on the same page, you might be fine, but I want to be able to see it again. Let's go crazy here. Let's see if we can find f of a plus 2.
We guessed it.
There's no guessing. Why don't you try that one? F of a plus 2. Okay, so I want to do another one of those, which means I'm going to have to make it up on the fly here. Let's see if I can do this. So let's say f is 1, 3, and 2, 4, and 5, 7. I'm trying to use all different numbers so we can see where they come from. And then let's do G being 4, 6, and 7, -1, and 8, 0. We'll find out in a minute if I've made up good numbers to make this problem work. And this time I want to find G of f of x. So which function am I concerned with first?
F of x.
F of x. It's on the inside. So I'm going to do my f of x table first, because that's where I'll start with. So 1, 3, 2, 4, 5, 7. I don't know what f of x is. I just know that it turns 1 into 3, turns 2 into 4, and it turns 5 into 7. And then let's do my g of x table. Again, I don't know what the equation is, but g turns 4 into 6, and 7 into -1, and 8 into 0. Well, I don't want to, yes, we'll do another table in a minute. So if I start with 1, on the inside, f turns 1 into 3. There is no 3, so this is kind of a dead end. So nothing happens with 1. If I plug in 1, I don't get a G out. I can get something out of F, but then 3 doesn't appear as a... another word you could use is the range of F becomes the domain of G, and it doesn't match. There's not a 3, so that's kind of a dead end. All right, let's try the next one. If I plug in 2, F turns it into 4.
6.
And G turns that into 6. So that means I want to start making that third table. If I plugged in 2, I end up with 6. If I plug in 5, F turns it into 7, and then G takes that 7 and turns it into -1. Whoops. I started with 5, I ended with -1. And so that 1, 3 was kind of a dead end, and then 8, 0 never even got used, so all I have is 2, 6, and 5, -1 for G of f of x.
I have a question.
Yes, sir?
When it says find G of x of x, will it give us that what you're showing, or will it give us to open circle? And we have to do it.
It could be either one. I could have, probably should have written this one like that, just to make sure we knew that those are exactly the same thing. G of f of x, G of f of x. Those are exactly the same thing. Okay, today's assignment is this next worksheet, but let's do some of this together. So why don't you try 1, 2, and 3? Some fractions, some negatives, some composition. So try 1, 2, and 3. All in terms of computations, but you have to understand what G of f of 0 means. So f of 0, oops, 4, is -5. Trying to skip too many steps. which means negative 5 is now the input to the g function. So I'll go look at the g function and plug in negative 5. And I think you get negative 33. Because 25 and 5 and 3, and they're all negative, so negative 33. Let's, in the interest of time, skip ahead. Let's turn to the back page. This is so your assignment is this worksheet. Number 12, that's might be easier to write it this way. So like find all the pieces and then put it back together. So 12 is like 4 problems in one, right? You got to find h of negative 2, f of negative 2, g of negative 2, and then put it all together. I mean, it's a lot, but it's not horrible because you know how to do all the pieces. Okay, the back is heavy concept, light computation. So that's good news for some, bad news for others, I guess. The first graph, this isn't as clear as it should be, but that first graph is f of x. The second graph is g of x. I mean, it tries to say it up there, but it doesn't really match them up very well. F of x is defined from 0 to 5. So this is the f of x graph. G of x is defined from negative 2 to 4. So this is the g of x graph. Okay, first question, f of 0. So which variable is 0? What value is that? Is that x or y? X. So this is asking you, or what this is saying is, when x equals 0, find y on the f graph. Now you're not going to write all that out every time, but that's what it's asking. F of 0 means if x is 0, what's y on the f graph?
8.
So it's not labeled, or it's labeled, but it's hard to read. 2, 4, 6, 8. So yes, f of 0 is 8. Didn't have to do anything other than understand what the graph is and what it's asking. Why don't you find f of 3 and g of negative 2? F of 3, g of negative 2. I haven't called on anybody today, so we'll get some voluntold here. So, Madison 15, Michael 16. Madison, f of 3? I think it is negative 1. X is 3. Y is negative 1. So f of 3 is negative 1. Michael, how about g of negative 2? Okay. So which graph is the g graph? The left one or the right one? Okay. Which variable is negative 2? X or y? X. So what this says is when x equals negative 2, find the y value on g. So go to the graph of g, look at where x is negative 2, and what's the y value when x is negative 2? So x is negative 2 right here. There's my y value at negative 2. So negative 2. Ben?
I think number 17 is 8.
Do you? I don't know what it is yet. G of 2. So what's G of 2?
G of 2 is 0.
G of 2 is 0, because I'm looking at the G graph when x is 2.
And f of 0 is 8.
And then f of 0 is 8. So again, some people like these because they get the hang of them and they're super easy. Like there's no fractions, there's no negatives, there's no multiplying. They're just looking at the graph, understanding what it's asking. We should make a lot of the tests like this. Let's skip down to 23. When does, we got to think backwards here, so the answer is 8. When does f of g of x equals 8? So 8's a y value, but a y value from what graph? From f. So when does f equal 8? When x equals 0. I like that. So that means g of x has got to be 0 for that to work. Well, where does g of x equal 0? Anywhere else? Where does g of x equal 0? 2 is right, but there's also negative 1 point something. Yeah, I don't know what it is. Negative 1.4 maybe. So that was kind of a backwards problem. The answer to f is 8. That happens at 0. But that means g of x has to be 0, and that happens at 2 and negative 1.4. 24 is kind of the same thing, and then 25 is another one of those ordered pairs where it's probably best to write out f and then g. 19? Uh-oh, I think I know what's going to happen on 19. What's g of negative 2? Negative 2. And then what is f when x is negative 2?
No solution.
No, there's not one. No solution, undefined, nope. Nah. Yes, all of those are correct. Okay, so the back of the worksheet should go pretty quick because there's not really any calculations to do. It's just thinking and looking at the pictures. The front of the worksheet takes a little time because you got to do the work. You got to do some computations on the front.